So in section 1.4, chapter 1, section 4, we'll talk about the relationship of perpendicular lines. So informally, we would call a vertical line one that extends up and down, like a flagpole. And on the other hand, a line that always extends left to right, we would call that horizontal. So we have a vertical line and a horizontal line. And when a vertical line and a horizontal line intersect, they appear to form angles that are equal in measure, congruent angles. So here's our definition. Perpendicular lines are two lines that meet to form congruent adjacent angles. So if I have line P and I have line Q, and I'm going to go ahead and number the angles here. Here's 1 and here's 2. These are adjacent angles, and if these lines are perpendicular, perpendicular lines will cause congruent. Angle 1 will be congruent with angle 2. Congruent adjacent angles. And you know what? Angle 2 will be congruent with angle 3, meaning the same measure. And of course, we're going to find out that they're 90 degrees. They're actually right angles. But for now, we're just sticking with the definition that they are adjacent and congruent. And by the way, the lines do not have to be vertical and horizontal. They don't have to be straight up and down. Any two lines, if they intersect and the adjacent angles are congruent, those would be perpendicular lines. And so we have the little box here, the little box notation. That's a notation that says that that is a right angle, a 90-degree angle. So that's showing that line M and line P are perpendicular, and that's how we would write that. Line M is perpendicular to line P. We've got that written right there. All right, so we can go on. By definition, perpendicular lines are two lines that intersect that create two congruent adjacent angles. But here we have a theorem, Theorem 141, Chapter 1, Section 4. Here's our first theorem in this section. If two lines are perpendicular, they meet to form right angles. All right, so if here's angle A and here's angle K, if they're perpendicular, all of these angles, they'll form four right angles. So how can we show that something is a right angle, a created angle? We'll do this once. We won't have to do this every time, but it is good to kind of practice. We are told that line AB is perpendicular with line CD. Well, according to Theorem 141, we would know that AEC. We would know that this angle is a right angle by Theorem 1. But let's go ahead and kind of do it the long way. All right, so we'll call this angle 1 and we'll call this angle 2 just to make our notation easier. The measure of angle 1 plus the measure of angle 2 have to equal 180 degrees, right? Because they create a straight line. And because the lines are perpendicular, we know that the measure of angle 1 will equal the measure of angle 2, because perpendicular lines create adjacent angles that are congruent, have the same measure. All right, so now, instead of this measure of angle 2, I'm going to replace that with what the measure of angle 2 equals. Using this first statement, the measure of angle 1 plus, I'm not going to put the measure of angle 2. I'm going to put the measure of angle 1. equals 180. I substituted, instead of measure of angle 2, I substituted something that was on the other side of the equal sign. 1 measure of angle 1 plus 1 measure of angle 1 is going to equal 2 times the measure of angle 1 equals 180. Divide both sides by 2, and we get the measure of angle 1 equals 90. And if a measure is 90 degrees, that must mean that angle 1 is a right angle. Now, we won't have to do this all the time, but it is kind of fun, especially in the beginning here, to make sure we understand how to put together that proof. All right, perpendicular is just one type of relation. The last part of this section has to do with relations. And in general, a relation connects one element to itself, 2 elements, or maybe 3 elements. The perpendicular relation connects 2 elements, 2 different lines. 2 lines could be perpendicular to each other. So let's look at some type of relations and what they connect. Is equal is a relation between numbers. So here's, 2 plus 3 equals 5. Relation of one side of the equal sign to the other. Is greater than also is a relation for numbers, relationship for numbers. So we would have 7 is greater than 5. We would have numbers using this equal sign and this greater than sign. Is perpendicular to, that only relates to lines. You wouldn't say angles are perpendicular. You wouldn't say points are perpendicular. You wouldn't say triangles are perpendicular. Lines are perpendicular to each other. Another relation is complementary. Only angles are complementary to each other. Angle 1 might be the complement to angle 2. Is congruent. Right now, we know that line segments can be congruent to each other. We also know that angles can be congruent to each other. So we could use this congruent relationship for either segments or angles. And then to throw one in that's outside of geometry, is a brother to would be a relation, and that would be for people, like Mark is a brother to Phil. So we're just talking about relations. In this case, we're relating 2 objects. But let's talk about some special properties for a relation. There are 3 properties. For one object to itself, we want to see if it's reflexive. For 2 objects to each other, we want to see if they are symmetric, or symmetric. And for 3 objects to each other, we want to see if they are transitive. These are properties of relations. A reflexive property only deals with a single object. A symmetric property deals with 2 objects, and we want to see if we can change the order. And will the relationship still hold? And for the 3 objects, we want to use 2 different groupings. We're going to explain all this. But for right now, just so you know, for any relation, we want to see if it's reflexive, symmetric, and transitive. So the notation for reflexive is A. Does A have the relationship with itself? For symmetric, that's the one that has 2, is the relation between A and B does that also hold for the relationship between B and A? I'm changing the order. And for transitive or transitivity, my relation between A and B and my relation between B and C, here are three objects, A to B, B to C, would it also hold for A to C? We're going to go through examples of all of these. All right, so let's look at the is less than relationship. We want to know, is it reflexive, is it symmetric, or is it transitive? The less than property. Reflexive. Is 5 less, I'm sorry, I put greater than. Is 5 less than 5? Is 5 less than 5? Let me clean that up there. No, it is not. 5 is not less than 5, it's equal. So we would say is less than is not reflexive. Is it symmetric? So, remember, symmetry, you're comparing two different objects. So is 5 less than 7? Is it also true that 7 is less than 5? You switch the order of the two objects. Well, no, it is not true that 7 is less than 5. So no, that relation is not symmetric.